Well, thank you very much for coming. I know it's been a great day out there on El Hierro, so I'm sure some people are a little tired from all the excitement out there. So I'm very grateful that you're kind of coming to hear me tonight. I like to talk about the volcanic history of the two main national parks tonight. And this is the Timanfaya National Park on Lanzarote, where we've been 2 days ago, and the Teide National Park on Tenerife, where we've been yesterday. There is a bit of a rivalry between the two, and I'll mention that later as well. But here I'd like to summarize the key features of the two islands and what makes the national parks. A few definitions to get going. Tourism, what is actually tourism? Well, it's the movement of people, and that means that as we are doing it right now, we're going from one place to another to see certain things and experience certain things. And this is, of course, a feature that has been growing over the last few hundred years. And particularly over the last 100 years, tourism has really taken off. And now we're moving towards definitions like volcano tourism or geotourism. And geotourism touches on geoheritage. And this encompasses global, national, statewide, and local features of geology. And this can be at various scales, from an entire volcano down to a tiny little feature that is of interest. And the particular geoheritage aspects here are about whether we can learn from it, whether it's important for science, important for the history of science as well. Have we learned something from this in the past? And of course, is it useful for teaching? So this is what I'm going to frame the different features in my presentation today within. So, and to get going on this, the last definition for today, what is a geosite? Well, a geosite is a location that has a particular geological or geomorphological significance. And it could also have a cultural or a heritage significance. And again, can be very large, can be very small. So Teide volcano is, if you will, a geosite, but then we might have smaller geosites on the flanks of Teide volcano, say a particular lava flow or a lava tunnel, or in geology we talk about outcrops, the particular occurrence of a rock in a certain place. So geotourism and volcano tourism is really taking off, and this is something that is what people call an ecosystem service. This is something the ecosystem volcano provides to us, and actually it goes back to Darwin. Darwin was one of the first to mention that the most beautiful landscapes are around volcanoes. And as we see in the Canary Islands, this is certainly true. It's spectacular landscapes, and this is one of the key features the tourist board in the Canary Islands actually pushes forward. It's the volcanic experience when you come to the Canary Islands that really matters. So we're here off the western seaboard of Northwest Africa, and here's the Canary Islands, and they span from about 150 to 500 kilometers offshore from Northwest Africa. And I mentioned him already, Humboldt, and he visited the islands for 1 week only in 1799. And he was quite an incredible individual. Believe it or not, he went all the way up to Teide volcano. At the time, it was still believed that you might get burned alive when you are that high up in altitude. But he survived, of course. And he actually complained about the lazy porters that he had. And yes, he did. And a few other things. I have a presentation about him and his time here in Tenerife a little later in the cruise. But one of the important things that he contributed to was the measurement of Teide volcano. And the important thing was, at the time, it wasn't quite clear how tall the volcano is. And people had tried before him to measure the height, and well, there was no single uniform measurement. And when Humboldt came, he confirmed a previous measurement by a French person. And we'll talk more about this some other time. And for that, he got famous. But he clearly recognized that it wasn't his main achievement. So he wrote down that in science, very often, it's the wrong person that is credited. And he had the greatness to actually admit to that. But still, we still cite his height, which is 3,718 meters. So he was the first to document it, confirming someone else's, and suddenly there was agreement amongst some scientists, and that made a huge difference. So he was one of the first geotourists, if you will, to the Canary Islands, and this is why I'm starting with him. But I'd like to move to Lanzarote first, the island where we've been a few days ago. And it's one of the smaller islands, and it's not very tall. It's only 670 meters in altitude, and it's got a population of 150,000 people, and it's got a population density of about 180 people per square kilometer. It's known for its white lava landscapes, and it also has some older shield volcanoes that are deeply eroded. Here in the top left, you see one of these older shield volcanoes, and well, you can barely see the volcanic features. It's a pile of rock that has been deeply eroded. You see the valleys, you see the ravines there. And then on the right-hand side, we have one of the younger lava fields from the 1730 eruption. There's also several volcanic cones spread all over the island and some volcanic craters. And there's the El Golfo crater in the top, in the bottom left. And it's a beautiful walk. If you ever have the chance, I recommend it highly. And there we have a crater that is right at the shore, a literal cone, and it has interacted with seawater, giving a peculiar color to the rocks. Another volcanic crater has been exploited as a salina, a salt production site, and it's still active today. It was a lot more productive in the past, but there is still activity there. So, and here's a few impressions of the volcanic landscape of Lanzarote. And here you have beautiful cliffs. And, well, of course, there's interaction between the rocks and the ocean. And this makes for spectacular sights. Having mentioned cliffs, there's a few taller cliffs as well, the Femara cliffs in the north of the island. And just in the background there, you can see La Graciosa, the island where apparently the pirate treasure from Treasure Island might be buried. So I've never actually been to La Graciosa, and I have it on my bucket list. I'm still hoping I find the treasure, of course. But let's go back to volcanoes for a little longer. So another feature is sinter cones. Sinter cones are tiny volcanoes. They are little volcanoes, and this is why sometimes Lanzarote is referred to as the island of 1,000 volcanoes, because it has a lot of these little cones, as we call them, sinter cones. And here you see them in various states of preservation. Some of them are older, some of them are younger. Usually the cones have an opening. This is where lava flows out. And this is a very typical feature. The opening is usually determined by the wind direction that has prevailed at the time of the eruption, because the material is blown in one direction, meaning the other side is actually receiving less material from above, and that's usually the opening. And in the Canaries, most cones actually have an opening in the same direction, because the wind tends to come from one direction, mainly. So, the El Golfo, we mentioned it before. El Golfo is a bit special, because here we had a volcano that actually erupted close to the ocean, and it interacted with seawater. You may or may not be familiar, there was this eruption in 1963 off Iceland, and a little new island formed, the island of Surtsey. And volcanologists call it Surtseyan type of eruptions. This is when magma and water interact, and what happens is the water is converted to steam. And when steam is formed, the volume increases by a factor of 1,000. And that leads to steam explosions. It's a very rapid process. And this is what we can see in the rock record. The fragmentation of the rocks is very intense, and usually the color is different. And this is what we see at El Golfo. We see these brownish layers of very fine-grained material. It tells us that this was a very explosive eruption at the time. Another amazing feature of Lanzarote is the use of volcanic lapilli. Lapilli is an Italian word. It means little stones, and the use of volcanic little stones in agriculture. And on the one side, it produces wonderful green areas on an otherwise very dry island. Yet, on the other side, it has a downside, as so often things have good and bad somehow combined, and that is we have large quarry areas on the island as well, and they are maybe not quite as scenic as the vineyards and the wine plantations. So here's a few impressions, and some of you may have had the chance to go to the cactus garden, which I'm showing here in the bottom right, and then they have the Lageria wine production or manufacturing vineyards, and there we have a lot of these little walls that shelter the plants, and they are a little bit, well, submerged in the ground, and this allows them to grow. So they're not very tall, but they grow very well in that condition. And this concept of using little lapilli, little stones, goes back to the 1730 eruption, and the local people call it picon, and picon has been used to fertilize the soils. And what was found back then was that the fields would bloom if there was a thin layer of this material on the fields, and this actually led to a doubling of the population of Lanzarote after the 1730 eruption. And it got so famous, the wine from Lanzarote, that it was even drank at the Vienna Congress in 1814. There's still menus where you can see that Malvasia wine from Lanzarote was drank there. So all the big important people in Europe enjoyed the wine from Lanzarote. So the wine is famous again today. There was a little bit of a spell where it didn't go so well. There was a pest that reduced the wine production on Lanzarote, but now it's coming back again. And well, it has quite a charm. But as I said, there's a downside. Using all this material for agriculture, well, the material has to be sourced from somewhere. And what we see is a lot of these scars in the landscape. I cannot hide them. They are a reality. So there's these quarries there, and a geologist will find them rather intriguing. It really has a shock effect on geologists because we can see it's not a natural landscape anymore. It's been modified. So here's a few more of those impressions, and here you see some of the changed landscapes, and here, particularly in the lower left here, huge chunks of material have been removed, and you can see that quite widely. Here's another use of volcanic craters that is maybe not quite so attractive, but it's good for geotourism because it hides this. This is a landfill site inside a volcano. And yeah, so you really need to know that it's there, otherwise you wouldn't see it. But then other features in volcanic craters are, for example, the salina, and let me say a word about that. This is a volcanic crater close to the ocean, and it allows water to penetrate the land, and then a shutter system has been developed, and this actually allows water to flush these salt areas, and then sun does the rest. It evaporates the water, and the salt stays back. And then when new water is required, new salt water, the shutters are opened again, and the water flushes the systems again. And it leads to very large salt productions. And it's very good for you. It's got a lot of iodine, and it's sea salt. And apparently that's very healthy, I understand. So another feature on Lanzarote that's quite famous is the lava tunnels. And you met Jörg today. He's, I think, he's one of the main caving people here on the island. So he likes to explore caves. It's not quite my favorite pastime, but you can go into these lava tunnels, and they often show quite a labyrinth of things and little sub-tunnels, and some of them are actually over 20 kilometers long. Can you believe that? So, and some of them are so large that artists like Cesar Manrique on Lanzarote, he was a local artist, but he got very famous. He used them in order to build certain attractions into them. So here's a few impressions of the Cueva Los Verdes, and there you even have specific animals that only live in those caves. I'm showing a little creature there, and it's actually transparent because usually it's dark in the caves, so color is useless to these creatures. Therefore, they often turn out to be transparent or black. But some of these caves are used even as swimming pools, as the one in the top left. And then I think I mentioned this before. There is some caves with restaurants in them, and some lava tunnels even with concert areas. So I've never been there to listen to a concert, but I picture it to be quite a spectacular experience. And here, a word about Cesar Manrique. This is the artist himself. He also built a lot of monuments that you can see above ground, not only in the tunnels, but he was very famous for working with the landscape, trying to integrate the landscape with art. And one of his most famous art pieces is actually in the bottom right-hand side. It's artificial, but he built that house where it appears as if the lava was creeping into the window of the house. And whoa, it's quite spooky, actually, I find. So I wouldn't want to live there, really. But it certainly creates emotions. So, and here's another building that he designed, and he tried to integrate them into the landscape, as I said, and he got world famous for this. So, yes, we mentioned this before. And here's a swimming pool he designed. And here's a few other features. So there we have skylights, holes in the lava tubes, in the lava tunnels, and he integrated this with the architecture above ground. And here is one of the viewpoints, the miradors that he developed, and this actually allows to view towards the north. And he has these hanging features that he created in several of the islands, and really on top of a cliff. It's almost a bit scary when you look down, but he has developed several of them all over the islands, and he got really famous for that. We can't really talk about Lanzarote without the big eruption of 1730 to 36, so I'll say a few words about that. And actually, I'm really proud today to have my mentor, Professor Caralcedo, here. And he was one of the scientists who really pushed research on volcanic eruptions, and he was instrumental in starting research to understand these eruptions already in the 80s and 90s, and I learned a lot from him. So let me report a little bit on this. He actually produced, or well, he didn't produce it, but he uncovered the map in the top left. The map in the top left is actually a drawing from the time, because the king in Madrid, he was very worried about the eruption. But back in those days, we couldn't have, photography or video cameras, so they sent an artist. And the artist produced an oil painting of the eruption. And if you look very carefully, let me see whether we can get this to work. If you see here, it's got little letters, NOPQ, and there's a list of all the features here. So this was really a map that was done on behalf of the king to report back how the eruption worked. It was one of the first geological maps, if you will, that tell us how a volcanic eruption evolved, how it progressed, and indeed, the artist shows that a large chunk of the island was covered with volcanic activity, and nowadays we can measure this more precisely. 23% of the island was covered with lava and ash. So here's the modern day mapping, and you can compare the features from the 1730 map to the present day map, and actually I'm quite impressed what people achieved back in those days. So here's one of those vents that produced part of the eruption, and this was one of the very earliest vents of the 1730 eruption. And if you go inside the crater, there's a hidden gem in there. There's an outcrop that has loads of these mantle nodules, and they produce a mineral called olivin, and olivin was already popular in Roman times and in Egyptian times, and Cleopatra was apparently very fond of this mineral. It has a calming effect and it energizes you at the same time, so they say. So this is something you can buy here on the island because there's plenty of it and it's not particularly expensive. The Timanfaya National Park is the area that hosts the main vent complex of the 1730 to 36 eruption. And it was established in the 1970s. And Cesar Manrique designed the logo, the little devil in the top right. That's the logo of the national park. And this builds on an ancient legend by the Aboriginal people. There was apparently a devil living inside volcanoes. Coyote, he was called. And he was not a very nice kind of creature. And whenever he was not happy, there would be volcanic eruptions occurring at the surface. So here's a few features of the lava landscape, quite wide lava fields and some vents, and there's a cone in the bottom right, which is called a hornito, a small little vent. It's a Mexican term, actually, where this was first observed and described. And then here is some of the volcanic ash fields that are connected to the Timanfaya eruption. It's almost like a desert of volcanic sand mixed with lava rock. And some of you may have had the opportunity to go to the national park itself. There's still a lot of residual heat in the vent areas, and the people, the rangers in the park, they would often put a little bit of straw into one of the vents, and then you have to wait for 10, 20 seconds, and then it ignites all of a sudden. It's quite spectacular. And another feature is the artificial geyser that they do. They pour water into a little hole, and then they have to wait for, again, 20, 30 seconds. And they're using the concept of water being converted to steam. And when that happens, as I said, the volume increases dramatically, and then suddenly it shoots out. And it's quite hot, actually, because of the residual heat. It's still several hundred degrees Celsius underground. And then some of you, I understand, had the opportunity to do the camel tour. So here's an impression of the camel tour as well. There's one downside to the Timanfaya National Park, and this is widely discussed in the geotourism sector, and that is you are not allowed to roam freely, unfortunately. And people find this sometimes a little limiting. So here I'm giving you a plot of the visitor numbers of the Timanfaya Park, and this is prior to COVID. Things have not fully recovered since COVID. But as you see on the right-hand side of the plot, there has been a little bit of a downturn to the visitors of the Timanfaya National Park. And I will contrast this to Tenerife a little later in the presentation, because now I'd like to take you to Tenerife, because there's one fundamental difference, and that is you're allowed to roam freely. So Tenerife is the largest island in the archipelago. It's got Teide volcano, 3,718 meters, and it's got a large population, over 900,000 people, and a high population density with 444 people per square kilometer. Tenerife is known for its triple-armed system. It has three main arms, the one to the northwest being the longest. And in the middle of it all, we have the Las Cañadas caldera, which is a somewhat older volcanic depression. And inside the Las Cañadas caldera, we have the new volcano, Teide volcano, growing, for which Tenerife is, of course, world famous. Teide is the tallest mountain in all of Spain, and people are worried that it might erupt. But the good news is Teide itself has not erupted in over 1,000 years. So here's Teide above the clouds, and this is the Sea of Clouds, already described by Humboldt, which is a feature that covers the lower part of the island. And this is also what sailors saw in the distance. There's this volcano sticking out, and the little tip at the very top, that's actually part of the very last eruption of Teide, which was a medieval eruption in probably about 800 approximately AD. So this is Teide on a glorious day, and you see little volcanic cones all the way up to Teide, and then you have the dark lavas from the top and the cone on the very top. The dark lavas is the lavas negras, well, the dark lavas, and they are part of this medieval eruption. And then there's some white rocks in the front, or cream-colored rocks. This is Montaña Blanca, the light-colored mountain, and this was erupting about 2,000 years ago. And likely, it was witnessed by the Aboriginal people, because the name Teide has an origin in the Aboriginal language. The original word was Enschede, and the translation to our understanding is hell. So the Aboriginal people likely witnessed that nasty eruption in 2,000 years ago and called it hell. The Spanish conquerors, they never saw Teide erupting, and they have a very different concept of Teide. For them, it's Father Teide, a very friendly look at Teide. In fact, so friendly that it's even a logo on the local beer. So here's Dorada, and Dorada is produced on Tenerife, and it's got Teide Volcano. Tomorrow we'll be in Las Palmas. And Las Palmas on Gran Canaria doesn't produce, or they don't drink Dorada. It's a sin to drink Dorada in Las Palmas. You have to drink the local beer in Las Palmas. It's called Tropical. So just a little recommendation so that the waiter stays friendly with you. So let's talk a little bit more about Teide Volcano and the rift zones and the long arm that goes off to the northwest. The northeast, rift zone is depicted here, and it's a really long ridge, several tens of kilometers long, and it's leading to the Anaga Massif in the very northeast of the island. And along this ridge, we have a crown of forest. You can even see it on Google Earth. You see that dark green area? That's the crown of forest, the Corona Forestal. And this is pine forest that grows because of all the sea of clouds. It takes its water from the clouds, and the clouds condense in the trees, and then it drips down, and it produces moisture in the ground. And this is where we have a lot of this pine forest growing in a little round area around the entire island. Now, what makes the ridge? If you're a geologist, then of course you want to look into this in detail, and there you can look into rock exposures. And what we find is these strange sheets of solid rock. We call them dikes, going back to dry stone dike walls in Scotland. But they're of course natural. They are cracks in the crust of the earth that was filled with magma rising up. Sometimes the magma also spreads out and spreads laterally, and then you get intrusions, and once they erode a little bit, you get rock formations like this one. It's called the sombrero because from a distance it looks like a hat. And here on the aerial image on the right, you see this round feature, and this is just at the side of the Las Cañadas volcano. The Las Cañadas volcano is a little older, and it was very, very explosive. It produced these large sheets of pumice-rich rock. We call them ignimbrites. And thank God, Tenerife has not produced anything like this in a long, long time. But back then, it would have really produced, or it would have caused all life on the island to be extinct. And indeed, we find a lot of fossils in those volcanic rocks, believe it or not. There is an extinct giant rat, the giant rat of the Canaries, and we find fossils of this giant rat in these deposits, so we know that most of the life was actually extinguished during those old eruptions, and they all go back several 100,000 years ago. Once they erode, they make spectacular landscapes. Here is a lunar landscape almost, and we have these more resistant pinnacles on top. They cause them to erode as little pillars. There's also lava caves or lava tubes on Tenerife, of course. Some of them are very long. And here's a few impressions of this. The longest is the Cueva de los Vintos. And there we can actually go inside. You can walk for several kilometers in there, quite spectacular. And the name comes from the wind because there's a draft. You can feel the air migrating through there. Now, how do these form? Well, we know from Hawaii, for example, that these form underground. Once we have a solid crust above these lava tunnels forming, you might still have flowing magma under this crust, and once it drains out, then you have an empty tube or tunnel. So, I mentioned this before in my opening presentation. Some of the ones on Tenerife, they're actually full of spiders. And it's a bit scary. So you touch the wall and then suddenly something touches your back. And, and then you try to look at it, but you can't see a thing because the spiders in these tunnels, in these lava tubes, they have changed their color. The lower spider here is actually one that lives freely outside, and they're very colorful, but the ones in the lava tunnels are black. So it's a bit creepy, and my daughters didn't really appreciate them so much. Now, sometimes the lava tunnels actually are remaining filled. So, and here we have this wonderful rose, as it's called, the rock rose, and this is actually a lava pipe where the lava did not drain out, and then you get columnar jointing, like the Giant's Causeway in Northern Ireland, for example, and there we see the cooling cracks. This is actually cooling cracks, and here you see that the lava tunnel was slowly solidifying inside, producing this wonderful ornament of rock that we see there. So a few words about the Teide National Park. It was established already in the 1950s, and it's a UNESCO World Heritage Site, and it's world famous because of that. And I'm also giving you a plot here with visitor numbers, and it's actually one of the most frequently visited national parks, not only in Europe but in the world. It actually rivals places like the Yosemite National Park, and it has actually a few more visitors than Yosemite. I looked it up, and this is also pre-COVID data. And in 2010, 2015, we had over 4 million people visiting the national park annually. So this is the national park from above. This is a NASA image, it's a satellite image, and there you see Teide volcano sitting inside the older Las Cañadas caldera. A caldera is a volcanic depression, and this was a larger volcano, and this likely collapsed laterally in one of those large landslides, and since then we have a new volcano growing, and that is Teide volcano. And this is mapping by my mentor, Juan Carlos, who looked at all these lava flows very carefully, and this is an impression, a geological impression of the different lava flows that have erupted from Teide, filling the Las Cañadas caldera, the depression, and all of them have an age date, so we know very well how this system is building up. And this has started about 200,000 years ago, and Teide is still slowly growing, but we now suspect it might have reached its maximum height. So here's a view from Teide down, and I understand some of you wanted to go up, but there were some restrictions right now. Unfortunately, there has been the forest fire, so it wasn't quite possible. The access was a little bit restricted in the last little while. So, but here you get a view at least, and this is looking down onto the Montaña Blanca area, the light-colored rocks there, and onto the Las Cañadas caldera wall. And just in the far distance, you see a little dark spot on the horizon. That's Gran Canaria, where we're sailing to right now. So here's a few impressions of the Las Cañadas caldera. And if there is enough rainfall, you even have temporary lakes up there, but usually they dry up very, very swiftly. And the geologists are arguing how exactly the Las Cañadas caldera formed. There's different ideas. Scientists have to argue, otherwise they're out of a job. So it's reality, I'm afraid. And some people like to think it was a lateral collapse, and I think there's a good set of evidence for that. Other people might think it is a vertical collapse, and some people want to make it extra complicated, and they say, oh, there was 3 vertical collapses. Well, I don't know what is exactly right, but I think the lateral collapse is certainly documented with an offshore debris avalanche. So we know that this is certainly a fact. Whether a vertical collapse occurred as well, we can debate that, of course. Then there's this ridge inside the caldera, which is a little peculiar, and it's called the Roques del Garcia, and it separates the eastern from the western part of the Las Cañadas caldera. And in that, we have this rather peculiar feature, the tree of rocks. I mentioned it before. It happens to be the most photographed rock on all of Tenerife. And, it's an erosional remnant, and sooner or later it'll go, it will fall down. But for now it's standing, and people, of course, go there, take pictures. And Well, people very frequently ask myself, so how does this come about? Well, the reality is I showed you some of these sheet-like magma intrusions earlier, and we had two of them, and they were actually filling the rocks, the rock mass, and you see them just up there in the very top, and they're very weathering resistant. And once there is erosion setting in, the lower rocks, they're more sedimentary in nature. They get eroded more swiftly, and the solid rocks on top, they are not getting eroded so swiftly, creating this rather peculiar pattern of a massive rock lump on top of a very thin, narrow little stem. So another feature in the caldera is the azulejos, the hydrothermally altered rocks. Azulejos means tiles. The Spanish and Portuguese, they produce these very colorful tiles, and we have these really awkwardly colored rocks sometimes at the caldera margin. So I'll bring you a little closer here, even with a sign there, the azulejos, and in this case they're turquoise, but sometimes they're also pink. And these rocks form when a lot of hot fluids circulate through the rocks, and they change their nature. And this is a peculiar phenomenon. And the local people have recognized the beautiful colors of these rocks for quite some time, and they're actually making pigments from that, and they are making paints from that, and all sorts of things. So here's one, I just couldn't help. Here's one to show where we actually have pink and turquoise together in the same rock on a very small scale. There's a €2 coin for scale. And of course, geologists are very amazed by these rocks, and you can spend entire PhD thesis just on explaining them. So here's more of those hydrothermally altered rocks. That's the pinnacle standing out, and then we have young lava flowing surrounding these rocks. So here we have geologically a very peculiar feature of very old hydrothermally altered rocks and young lava flowing around them, and it's an El Dorado for geologists, of course. So, and then we have these rather awkward rocks. And this is also a form of alteration. This is an interaction of water with rocks, but at a cold temperature. And we call that onion skin weathering. And this is where flakes of rocks start to become unstable, and they fall off. And they would then reduce the rock mass. So this is how mountains are actually reduced ultimately by becoming unstable. So in the bottom right, I'm showing a little diagram here where, for example, a hexagonal rock column starts to lose its edges by this alteration process, and eventually all this rock material will degrade to a very flat island, for example, like Lanzarote. So this is known as onion skin weathering, and you see some of this in the Las Cañadas caldera as well. Here's a few rock masses that are very good for teaching, and if you had any contact with geology before, then you probably heard about cone sheets and ring dikes and things like that. And you see in the caldera margin some of these sheet intrusions again, and they're very well exposed. Often they're a bit rusty, but they're spectacular rock features. So here's a few more of them. Here you see them weathered out, and then they stand proud. The local people here in the Canaries have a word for it. They call them tabaruchas. These are effectively natural walls that stand out where the softer surrounding rock has been removed. And sometimes when these rock masses are actually not sheets, but more plugs, then they look like this. And this is one of the most famous intrusive rocks in the Las Cañadas caldera. It's called La Catedral, the cathedral. And it stands proud, and you see the columnar jointing in there as well. Let me zoom in a little bit. Here it is. Here you see the columnar jointing, but it's lying flat, not unlike at the Giant's Causeway where it's vertical. It's lying flat because cooling was from the sides, not from the top. So these are cooling cracks. And I don't know, I don't have a scale in there, but you can see the bushes there, and well, it would be actually very, very high. It's several hundred meters tall, so humans would be dwarfed next to them. So Teide is clearly the centerpiece of the national park. I talked about the features in the Las Cañadas. Now a few words about Teide volcano itself. So here's Teide, and well, as I said earlier, the local people revere Teide. It's Father Teide. It's got a very protective aura, and people are very fond of Teide on Tenerife. And here's a few more impressions. Quite a scenic volcano. And of course, it's the centerpiece of the national park. There's a cable car going up, at least most of the time. And there's also some wildlife that's protected. There's some large lizards in the area, the giant Canary lizard, for example, which I'm showing here. And you can just about see the cable car poles on the image in the center. That brings you up to the area of the little plateau just before the main peak. And the main peak is off limits. You need to have a special permit to go up there. And here again, the view from up there, and I'll take you a little further. This is the cable car. If you ever have a chance, I recommend it. But it depends on the weather. It depends on a lot of factors, whether it's open or not. So this is the view from the very top, from the crater, and of course there's a bit of sulfur up there, and often you get some fumaroles as well, get some hot gases coming out, and here you can see this. But once you have a permit, you're allowed up there. It's actually not particularly dangerous. The biggest risk up there is actually altitude sickness because it's very high. So here's a few more impressions, and Teide often has a cloud cover. At the very top, clouds get stuck, and the local people call it Teide's hairdress. It often has peculiar clouds on the very peak. So here's a few of these fumaroles and a few sulfur crystals that you might find up there. And very close to the peak is a very intriguing feature. It's the ice cave. And the ice cave actually is already mentioned by Humboldt. Humboldt was a bit annoyed with his porters, and he expressed this rather clearly in his accounts. And one of the things that he was not happy about is that the porter said they have to go to the ice cave. And he was very perplexed about this, and only later he found out that what really happened was they went into the ice cave to get ice, to sell it downtown so that people can make sorbets from it. And it was actually a really prized commodity, can you believe it? So, and he didn't quite understand that the porters wanted to make an extra penny at the side. And here, the issue is that there's a cave. Often it's below zero overnight, and all the precipitation there freezes over. So there's a little place on the island, which is usually quite hot near the coast, that has ice all year round. And of course, once you're up there, you take a little bit to sell it downtown. So then there is a side cone to Teide. Teide is the main cone, but there's a side cone, and it's called Pico Viejo, the old cone. But that was a bit of a misconception, as so often these things are not entirely right. Actually, Pico Viejo is a younger cone that grew on the flank of Teide volcano, and you can walk there. You can walk there freely without permit once the restrictions after the fires are lifted. And here's an impression of Pico Viejo viewed from Teide, and you see the dark lavas, the lavas negras in the foreground of that image. And what happens is, if volcanoes grow too tall, magma will find it very hard to go to the uppermost peak. So it will start to actually produce vents on the side, on the flanks of the volcano. And this is likely what happened here at Pico Viejo. So here you see the crater of Pico Viejo and Teide crater, or Teide peak, in the background. Then a few words about lava types. It's an El Dorado of lava types. Many European universities bring their students to Tenerife to study volcanic processes, and there we have different types of lavas, and I'm going to show you a few of those. Here's the lavas negras again, the black lavas from the summit area, and they form these little, channels, if you will, with little boundaries, levees, and the lava would flow inside these channels, and there it's a little insulated, heat insulated, so it can flow a little bit further. Here's a few of those impressions. Here you see the channels really well, and the channels, they are forming these solidified margins, and the main lava would increasing flow inside the channels. Then, of course, you have Pahoehoe lava. It's a Hawaiian term for ropey, flat surface lava. And this is a bit like what I would say, it's a bit like skin on a hot chocolate. It wrinkles up if you blow against the skin. And this is what we often see. The surface of lava is a little bit harder. And if you have flow underneath, it creates these wrinkles at the surface. It's a compression feature. So, and here we have a lava flow that was stopping halfway down the hillside. It's known as the hanging lava flow. And this is, unlike water, lava can actually freeze halfway down a hillside. It doesn't flow all the way down. I mentioned these before, hornitos. These are rootless vents or rootless cones, and they often happen when you have lava flow underground. If there's a few holes in the surface, then there can actually be little pileup of lavas happening, but the main flow is actually underneath. And it's a useful feature because it allows you to map potential lava tunnels underneath. So here's a few of those in the forest in Tenerife, and there you have some hornitos, so you can work out that there was a connection underneath. One really, really intriguing feature is Teide's eggs. These are these large lumps of dark material from the lavas negras that are found further down the hillside. And there you see some people for scale. They're really, really intriguing. They're not bombs, because otherwise there would be impact sacks or impact craters. So for a long time, people didn't really know what was going on with them, until the 1971 eruption on La Palma, where suddenly there was live observations of how lava balls, as they're now known, or Teide's eggs, would form. And what actually happens is these are bits that roll down like a snowball from the rear of the lava flow. They run over the advancing lava flow, and then they actually accrete layers and layers and layers, and they become really big, and then they continue rolling down the hill. And actually they're a little dangerous, because imagine there is an eruption and you think the lava is confined up there, but suddenly you have this thing rolling down. And I'm going to show you a video when I'm discussing the La Palma eruption, because Juan Carlos and myself, we were standing there during the La Palma eruption, and suddenly, out of almost nowhere, there was massive lava balls running towards us at enormous speed, like cannonballs. And volcanologists are trained to not run away from lava balls or anything that flies through the air. You are told to watch them. And like a bad goalkeeper, you step aside. So if you run away and you don't know where they're going, they might hit you. So you have to be very brave as a volcanologist. So a few more features here, and this is the peripheral rocks in the Teide setting. We have a lot of peripheral rocks. The Montaña Blanca, the light-colored mountain, is part of them. And here we have a lot of lava flows, and these are a little bit more silica-rich. We call them phonolites in the rock composition, and they have been flowing to the north, down into the valleys, and they have reached the sea there. So here we can put the geology on top of them. Here's the feature in the landscape, and we can identify different lava flows, so we get an idea of how lava would progress down the hillside. Here's Montaña Blanca, the light-colored mountain, and this, as I said, was an eruption 2,000 years ago, and we had no such eruption in the recent record. And this brings me to the last part of my presentation, and that is the historical eruptions. So here, the historical eruptions on Tenerife. Well, there's a number of them, not as many as on La Palma, but there was an eruption in 1704, and it led over to 1705, quickly followed by an eruption in 1706, and then 1798, and then the last one was 1909. So here the features are given in red on the main map, and there was one eruption which is a little bit in between the prehistoric record and the historic record, and that's the 1492 eruption, or the Columbus eruption. So here, this is the 1492. There's the vents there in the distance of that image in the center. And the story goes that Columbus was actually sailing from Gran Canaria to La Gomera. And he describes a fire in the Sierras of Tenerife. And he says all the sailors were really worried about it, but he explained to his sailors that this is not an unusual feature. It's like at Etna. And he was right, actually. So we have the first historically documented eruption on Tenerife in the logbook of Christopher Columbus before he discovered America. So the 1704-1705 eruption was actually a triple vent eruption. It was an eruption system that came up in several places, close to Teide volcano, but also in the Guima Valley, a little bit further down. And here I'm showing you the three vents. This is Siete Fuentes, Fasnia, and Arafo, named after the village of Arafo. And here you can just about see it. Let's see whether I get this. So here's the vent in the higher part of the Guima Valley, and you see the dark rocks there. That's the lava flow of 1705, and it was flowing towards the sea, but it never reached the sea. Here is the other vents of the 1705 eruption up there, and this is the snowy part now. It's a winter image, and you see the dark lava, so they're only a few hundred years old. And here's another one up there in the barren landscape. The dark new lavas, they stick out very well. The 1706 eruption was in a slightly different part of the island, and that was a big economic disaster, actually, because what happened was the lavas did flow down towards the coast, and they reached the coast. They reached the coast, coincidentally, at the village of Garachico, which was the main port to the Americas at the time. And the lavas was, well, they were filling the harbor area, and it made the harbor very, very small, and it meant that no ship traffic, no naval traffic was possible towards the Americas for some time. And this eventually led to other ports being opened, and finally, actually, Santa Cruz de Tenerife was becoming the main port on the island after Garachico was rendered useless after the 1706 eruption. The 1798 eruption is on the flank of Pico Viejo, and it was entirely up there in the mountains. Nobody was anywhere near there. Some French researchers were there, they witnessed it, and that's where the drawing in the top left comes from. But there was no harm done because nobody lived up there in that remote area. So this was a rather benign eruption in this context. And here's a few impressions of the vents of the 1798 eruption. And you can look inside the crater, so here's an impression of that. And the final eruption on the island was in 1909, and it was also up there in the remote areas. And it was a very short eruption. It only lasted 2 or 3 weeks. And in the bottom right, I'm showing an image that there was little tourist groups going up there with donkeys, and they actually witnessed the eruption, and then we had some early photos of the eruption as well. So I'd like to close now by adding a little bit of advertisement. So if you are interested, and that means my mentor Juan Carlos and myself, we have a few books on the geology of the Canary Islands, but also specifically on Teide volcano, and they are of course available. We had a commission to write a geosite book for the national park, which you can buy in some places on Tenerife, and hopefully soon also online. And just very recently, we produced a children's book for early learners, for young learners, Tenerife and Teide volcano. So, and in those books, we're describing all the hiking routes that you can do in the Las Cañadas caldera and around Teide. And you can see all of these eruptions and these deposits there. And this makes the Las Cañadas area and the Teide National Park a really spectacular area because it's freely accessible, unlike the Lanzarote situation with the Timanfaya National Park. So, and this led to the situation on Tenerife being really praised for many years, and it's a model for how a national park could be run. And we have a geotourism course back home in Uppsala at the university, and I give a few lectures in there. And this is my prime example of how this could be managed. And here's a newspaper clipping saying that the Teide National Park is breaking all the records because of exactly this combination of outstanding nature, UNESCO quality nature, and the accessibility being provided as well, leading to these very large visitor numbers that I've shown you before. However, there is one dark side, as so often, life is not so simple, and that is that both the Timanfaya National Park as well as the Teide National Park are, of course, spectacular sites of natural beauty, but they are also exclusion zones. If you look very carefully, there is clear records in the governmental domain that say these things are national parks because there is volcanic risk. You should not actually have people living there. And to ensure that there is no new people coming there, settling there, building up cities and villages, that's why they have become national parks. This was the big problem in La Palma, where the area is not a national park. Many people flock to it, and if you have an eruption, then it can lead to a lot of damage. So these areas are for us to enjoy, and they're actually designed to keep people out, at least in terms of permanent settlements. So this brings me to the end, and my last bit of advertisement. Tomorrow we're going to be in Las Palmas, and if you're interested in geology and you have nothing better to do, there will be a little lecture by myself for the Royal Academy of Sciences in Las Palmas tomorrow evening at 6 o'clock in the Gabinete Literario, which is actually in the Old Town. It's very scenic, and you're, of course, very welcome. It's public, and I'll talk in English because my Spanish isn't good enough. So, thank you very much, and I hope to see you again.